So the atomic number is represented by the letter Z. And the atomic number is just the number of protons that are in the nucleus of the atom. So this is actually unique for each element. So if you have a periodic table, grab that real quick. So if you look at the numbers, it's usually the largest number on the periodic table. It's the number located above the symbol in the periodic table. So for example, oxygen. Oxygen has the Oxygen has the number 8 above it. So that tells us that it has 8 protons. So all I have to do to figure out how many protons an element has is look at that number on the periodic table. So it's the same for all the atoms of that element. So all oxygen atoms have 8 protons. That's what makes it oxygen. All chlorine atoms have 17 protons. So again, that's unique for each element. That's not going to change. All of those atoms have that number of protons. So again, the neutral atom has the same number of protons as the number of electrons. So if I wanted to know how many electrons I have for my neutral atom, I can do the same thing. I can look at the number or the atomic number on the periodic table to show me how many electrons. Now I can't do that if I have an ion because the number of electrons changes for the ions. Okay, so we have atomic number, we have mass number. Mass number is the number of protons plus the number of neutrons. Now I can't look this number up on the periodic table. Okay, this is something I just have to do. I have to take protons plus neutrons to get my mass number. And I'm going to talk about the average atomic mass number that is on the periodic table, but this is not the same thing. Okay, each element has a symbol. So again, have your periodic table out with you. Some symbols have one letter, some have 2 letters. So here in the table, oxygen is zero. Oxygen is O, carbon is C, sulfur S, hydrogen H. So that kind of goes along with the name. And then the 2 letters, the first is going to be capitalized, the second has to be lowercase. Okay, so make sure you do that. If you put, just to give you an example here, if I have CO and if I have CO, those are 2 different things. So C with a little o is cobalt, big C, big O, that's carbon and oxygen. So you have to be careful. You have to make sure you're writing the first letter capitalized, the second lowercase. So these go along with the names as well. We have calcium as Ca, bromine Br, chlorine Cl, chromium Cr. But that's not always the case, unfortunately. Sometimes the symbol does not go with the name. So here's some examples. Potassium, the symbol we use is K. Gold is Au. Lead is Pb. So nothing about that symbol goes with its name. It's because those symbols were taken from names the elements used to have. So potassium actually used to be called kalium, and they changed the name, but they kept the symbol. So that makes it a little difficult sometimes for us to remember these symbols. Okay, you don't need to know their previous names. I just want to show you why they have the symbols they have. So you do need to know their current names and their symbols. So start working on those. I always tell people start working on the names and symbols of elements 1 through 36. Let me write that down here. So 1 through 36, so that's going to be hydrogen through krypton. So just memorize the name and the symbol. Okay, you don't need to memorize atomic number or anything like that. Okay, just name and symbol. So I'm going to have a periodic table for you on Canvas to show you what periodic table you're going to get to use on your test. But for now, just start memorizing the name and symbol of elements 1 through 36. Okay, so the way we represent the symbol, the atomic number, the mass number all together looks something like this. Okay, so we write the symbol of the element. So we have just an example X there, our symbol. The mass number is located at the top and the atomic number at the bottom. So here we have carbon as an example. So the symbol for carbon is just C, and carbon's atomic number is 6. So all I have to do to find that out is look on the periodic table and see I have 6. Okay, so that'll go down here at the bottom. And then the mass number for this carbon is going to be 12, and I'm going to show you here in a little bit how we figure out mass number, but just remember it's protons plus neutrons. Okay, over here we have gold. Gold is AU for the symbol. It has an atomic number of 79, so remember I just looked that up on the periodic table. You'll see 79. And then the mass number is the atomic number plus, or I'm sorry, the protons plus the neutrons, and it's 198. Okay, so that's the correct way to write the symbol, mass number, and atomic number all together. Okay, each element has isotopes. So isotopes have the same number of protons, but they have different masses. Because remember, we talked about how the elements, what makes it that element is the number of protons. So that's never going to change. Carbon is always going to have 6 protons. That's what makes it carbon. But they can have different mass numbers. So if their mass numbers are different, then it's the neutrons that are different, okay, between each isotope. So we have 3 isotopes here of carbon, and we name them based on their mass number. So here we have carbon 12, carbon 13, and carbon 14. Again, they all have 6 protons, okay? But you can see right here, their neutrons are different. So it makes their mass number different. So that's why we named the isotope based on its mass number. So all elements have isotopes, but just remember their protons are going to be the same, but their mass numbers will be different. So we have to take, to find the mass number, we have to take protons plus their neutrons. Okay, we are going to fill out this table here of different isotopes. So first up, we have oxygen 16. So remember, that's how we named the isotope, is based on its mass number. So oxygen 16. So the first thing we want to answer is how many protons do we have? Okay, so all you have to do is look at your periodic table, go to oxygen, and you'll see that its atomic number is 8. Right? Okay, so neutrons, we know that, before we get to neutrons, let's hop down to mass number. The mass number is already here. It's, let me try that again. It is with our symbol because it designates what isotope we have. So all we have to do is write that down here, oxygen 16, so it's 16. Okay, so now that we know the mass number and the number of protons, we can figure out the number of neutrons. So all I have to do is take my mass number, 16, subtract out the protons, which is 8, and that gives me 8 neutrons. Okay, so again, mass number was 16. I have 8 protons, so that leaves me with 8 neutrons. Okay, and then next it's asking for electrons. There's no charge on this symbol, right? It's just oxygen 16. There's no charge, so that means that the electrons are equal to the number of protons. So I'm just going to write down the same number I wrote with protons, and it's going to be 8. Okay, on the next one, they don't give us a symbol. They just give us number of protons and neutrons, so we have to figure out what element we have. So we're looking for an element with 26 protons. Okay, so you should see that that's iron. Okay, so we can write down iron. The symbol for iron is Fe. Ooh, having trouble writing on this. Okay, let's hop down to electrons. So it's going to be a neutral atom. So we're going to have the same number of electrons as we do protons. So we're just going to rewrite 26 there. Okay, and now we need to figure out mass number. So mass number is protons, which is 26, plus neutrons, which is 30. So that gives us 56. Sorry. There we go, 56 for our mass number. So I'm going to put that with the symbol because that designates which isotope I have. So this is iron 56. Okay. Next one, they give us 64 neutrons, 48 electrons. We know that they're all going to be neutral atoms. So we're just going to take 48 and put that for our protons. Okay. So let's figure out who has an atomic number of 48. That's going to be cadmium, which is Cd is the symbol. Okay, and then to find our mass number, we have to take protons plus neutrons, and that gives me 112. Okay, so we have cadmium 112 is the isotope. Okay, next one. We're only given number of electrons. Okay, so we're going to take electrons. We're going to put that number for our protons since we have a neutral atom. And then we figure out who has 50 protons or their atomic number, which is going to be 10. The symbol for 10 is Sn. Okay. Oh, you can't see it on here. I kept wondering. Oh man, I just messed up. Okay, that's okay. So that 118 is on there. So my little deal was hiding it. Oh, there we go. Whew. Okay, so I'm going to rewrite it right here. 118. Okay. So we have 118 for our mass number. So to find our neutrons, all we have to take is our mass number, 118, minus our protons, and that gives us 68 for our, let's try that again. 68 for our neutrons. Okay, so we're going to put our 118 up here with our symbol. That kind of looks like an 8. So we have 10, 118 is our isotope. Okay, last one. We have 79 protons. So if you look at your periodic table for 79, that's going to give you gold. And the symbol for gold is Au. So if we have 79 protons and we have 79 electrons, and we have our mass number, it's 197. So we're going to find our neutrons. So it's going to be 197 minus 79. And that gives me 118. Okay, so this is going to be gold 197. Okay, so be able to do that. And remember, the mass number comes from protons plus neutrons. You'll never look up the mass number for an element or an isotope on the periodic table. Okay, if you do, you might possibly get it right, but you'll probably get it wrong. So don't get in the habit of doing that. Okay, mass number is always protons plus neutrons. Okay, so let's talk about the number that is given on the periodic table. So we have the atomic number. We know that's the big number above the symbol. And then we have the average atomic mass of the element, and that's the number below the symbol. Okay, so what they do to find the average atomic mass is they take the weight of all the naturally occurring isotopes of that element. Okay, So earlier when we were talking about isotopes, I gave you an example of 3 isotopes of carbon. I think we had carbon 12, 13, and 14 maybe. I can't remember. Yeah. So if those are the naturally occurring isotopes for carbon, what they do is they take the weight, the masses of those isotopes, and then they average them together. But they don't just average the masses. They also take into consideration their percent abundance in nature. So just to show you here, carbon 12 is the isotope of carbon that's found most in nature. So, anytime they find carbon in nature, 98% or 99% of the time, it is carbon 12. So they do find a small percentage of carbon 13, carbon 14, other isotopes of carbon, but they're at a much smaller percentage. So we have to take that into consideration. That's why we can't just average the masses of these isotopes. We have to take their percent abundance into consideration. So to do that, on our first example here, okay, so what we do is we take the percent abundance, so it's 98.93%, and we divide it by 100. See if I can squeeze 100 there. There we go. And that gives us 0.9893. Okay, so always divide that percentage by 100, and we get 0.9893, and we're going to multiply that by the mass. Okay, so the mass number is right there, carbon 12. Okay, and then we do it again for the other isotope. So here's the other isotope. We're going to divide the percentage by 100 and get 0.0107. And then we're going to multiply it by its mass. But here they've actually given you some more significant figures. And sometimes they do that. And that's okay. So you do that for each isotope. So you could have 2, you could have 3, 4. You just keep doing that. And then you add all the isotopes up. And here we get an average of 12.01 AMU. Okay, so our numbers should lie in between the isotopes. So we have carbon 12. Let's try it again with this color. So here we have carbon 12 and carbon 13. So the average should lie in between 12 and 13. But since carbon 12 has such a high percent abundance, the number should be closer to 12, and it is. Okay, so that's a really great way to check yourself and make sure you did it correctly. Okay, I have one more example I want to give you. Okay, if we have boron 10 at 19.8% and boron 11 at 80.2%. What is the average atomic mass? Okay, so we know we're going to divide this by 100. That's going to give us 0.198. And then we're going to multiply that by the the mass of boron 10. And they did give you a few more sig figs here, so 10.01 AMU for boron 10 and 11.01 AMU. Sorry, 0.01. There we go. For boron 11. Okay, so we're going to multiply that by 10.01. And then we're going to add that to the next isotope. So we're going to divide this one by 100. 80.02 divided by 100 is 0.802 times its mass, which is 11.01 AMU. Okay, and again, if we had another isotope, we would just keep adding all the isotopes until we run out. But we just have the 2. And our answer is 10.81 AMU. Okay, so again, it should be in between 10 and 11. And since 11 has a higher percent abundance, it should be closer to 11, and it is, right? So again, that's a really great way to check. Make sure you did it right.